Welcome to a new test and teardown video. Look at this unit. It's not that big or anything. And the case is also a MK, is what it's called. I believe this is like a tone generator, 2-tone out, low, normal, high or something. But the on-off switch you can't move, so I need to clean that. And then we got, is that dB? Probably. And then we got some level here and some level. Oh, this one you can't move. So maybe this is also level of the other tone. I don't know yet what is going on. I can't test this because I can't move this and I don't want to break it. I really try to move it, but it's not going to happen, so. And there's no other indications whatsoever. So, and this one moves quite alright, but not that one. Alright, let's do a little bit of fixie fix and then let's have a look. So let's look at this. Now I've been cleaning up everything and now all the switches work. Look at that, easy, easy. And the level here is just, ooh, nice and smooth, huh? Imagine what a little bit of cleaning can do, and I didn't even open it yet. Now everything here is super smooth. Oh, one of my super nasty tricks, but see how good it works? That is just amazing. So, let's look at the output of this 2-tone unit. So this is low, I guess, but I don't understand N. That should be both, right? So low is, here we go, 1.3 kilohertz, and then we go to H for high, I guess, 1.5 kilohertz. And if I put it in N, we get both of them. And of course I can adjust the balance, like one of them or the other one. So in the middle, I can fine tune both of them to be exactly the same, and then the level. And also I got this dB attenuator here. That seems to be working quite well as well. So this unit is definitely working. Let's play a little bit more with this 2-tone generator. If we look at this spectrum analyzer here, so this is the high frequency, and this is the low frequency, and this is of course the harmonic. So try again and have a look at the harmonic. So this is the third harmonic. Here we go, and here we go, right? Let's take both of them and see where are the harmonics now. Isn't that funny? So there's a little bit to study here about intermodulation and how stuff works out when it's mixed. So I think this is actually a really interesting box to play with, especially to measure the difference between, this is the wanted signal and this is the harmonics, but this is of course what comes out of the generator. And now try and pull this through like an audio amplifier or a radio system. This is of course what this is meant to be used for, and this is why it is those frequencies, they're very close, and this is because the frequency range of FM receivers or AM transmitters and all that kind of stuff is in this very low speech area of the frequency band. Yeah, so this is just what I wanted to show you guys. So this is the high frequency, and then let's play a little bit with the output level here. If I try and turn up the audio level, ooh, look what happens. Now I'm overdriving the output amplifier in this unit, and then I get a lot of harmonics. And if I crank down the output, see what happens, and suddenly all the harmonics, they just go away. This one is actually a little bit interesting. Is that the, no, it's not noise from the balance. Yeah. Haha. This is actually this is the low oscillator that's still running in here. See, this is the low oscillator and this is the high oscillator. So when I'm running in high oscillator, there's a little bit of contamination on the output. But when I'm running the low oscillator, there's also. Let's look inside this beautiful unit. And this is definitely homemade, home designed and home built and everything, right? I kind of like the way that this is made. But of course the way with the resistors you see here in the middle of the picture, this is the high-low both switch. This is of course why you have this mix of both of the signals. So this is the mix pot and the two yellow wires, orange wires, they come from two op amps. So the TAA865A, that'll be an op amp, and here we go, the two oscillators. This dude really knew his transistors and oscillators and amplifiers and everything. See, the output amplifiers, of course, also homemade with a transistor. Isn't this just fantastic? And attenuator, of course, also with all the resistors and stuff. It looks like it's been calibrated a little bit with playing around with some resistors. But yeah, sorry, funny thing here. Let's see if we can zoom in and get this in focus. Look at this regulator. This is an 7812, so this is 12 volt out. But look at the golden pins. If you look a little bit careful, let me see if I can get this. Can you see? It says BCE. This is of course because of this the pins and the whole base of this IC, this casing for the ICs, that was of course mainly used to manufacture transistors, and then they invented the 3-pin regulators. Okay, so let's just put it in this house that we're already building transistors in, and then just stick on a new type number. But of course the pins down here still say BCE. That's just fantastic detail of the old days. And again, this guy always just loved to use only 2 rectifier diodes and then center tapping. This is just his favorite method to do this. And then 2 capacitors, so that's really good. But what I would have done today, if it was my design, and you still, plan to use 2 capacitors, so how about taking one of the capacitor between this signal and that directly, and then 2 resistors down to the other capacitor and the entire board. Now it's completely ripple free and isolated from mains and even from capacitive couplings from mains. So that is what I would have done if it was really necessary or needed to have it nice and silent. Still we see all this mini mount. Super famous, like well used in the 80s and 90s, and I think this unit is like 70, 80, 90s something. It is quite old, this design. I can't see anything telling me any kind of date indication other than this kind of the style of the components and the general age of those components. So it is quite old, but well designed, well built. Yeah, I kind of like it. So thank you for watching. Hope you had fun.